Okay, so today we're diving into something that feels, a little bit like magic, but is actually pure, cold, hard logic, how a machine can learn to read and actually understand human language, step by step. I mean, really think about it. You ask your smart assistant some random question, and it just gets it. Or you start typing a text, and your phone basically reads your mind, finishing the sentence for you. Well, that's not magic. It's actually a super powerful field of artificial intelligence that's working away behind the scenes. And that field? It's called natural language processing, or NLP for short. It's the science and the art, really, of teaching computers how to read our messy, chaotic, often confusing human language and turn it into structured information that a machine can actually work with. So how does a machine even begin to go from just a jumble of words to actual understanding? Well, it uses a process that's a lot like a factory assembly line, one that transforms raw language into a finished, structured product. This whole process is what we call the NLP pipeline. It's the series of stages that takes raw text in one end, pushes it through a bunch of different steps, and then, on the other side, out comes structured, meaningful data. You gotta know, each step builds on the last, getting the machine closer and closer to real comprehension. So let's put this whole thing to the test. We're gonna follow one single sentence through this entire assembly line. We'll watch it get taken apart, cleaned up, and then enriched with meaning until the machine can finally make some sense of it. Let's see how it works. All right, first stop on our assembly line, the deconstruction phase. Before a machine can even think about understanding a sentence, it has to break it down into its most basic parts. It's kind of like taking apart a Lego model, brick by brick. And this is the sentence we're going to be following today. It translates to Sumbulus sprang to his feet and gasped, "Thank you, I'm having a dream." I mean, it's got everything. Names, actions, quotes, punctuation. It's the perfect example of the kind of messy text a machine needs to figure out. The very first job is something called tokenization. This is where the machine just scans the sentence and splits it up into individual units. Words, punctuation marks, symbols. And each one of these little pieces is called a token. And just like that, with one simple step, our sentence isn't a long string of text anymore. Nope, it's a neat, orderly list of tokens. Words like sumbula and sprang, and even the punctuation, they're all now individual little bricks, ready for the next stage. And this is so important. Separating the punctuation is how a machine can tell the difference between "that's great" and "that's great." See the difference? Okay, so now that we have our little pile of word bricks, it's time for cleanup. In any language, some words are just more important than others. To help the machine focus on what really matters, we need to filter out all the noise and simplify the important words. First up, we get rid of what are called stop words. These are the most common words in a language, things like the, is, and They're essential for grammar when we talk, for sure, but they don't add a ton of unique meaning. So getting rid of them helps the machine zero in on the words that actually carry the weight. Next, we need to deal with all the different forms of the same word, like run, running, and ran. There are two main ways to do this. The first is stemming. It's a fast and kind of crude approach that just chops the ends off of words. The other is lemmatization, which is way more sophisticated. It actually uses a dictionary to find the real root word, or lemma. And here you can see the difference right in front of you. On the left, stemming is just a rough chop, which can sometimes leave you with a word that doesn't even exist. But on the right, lemmatization is like a smart dictionary lookup, and it correctly finds the true root word. It's basically the difference between using a blunt axe and a precision scalpel. So, with our words all cleaned up and simplified, the pipeline can now start to add layers of meaning. This is where the machine goes beyond just seeing words and starts to understand what they do and what they represent in the real world. The first step in adding some meaning is part of speech tagging. Do you remember diagramming sentences back in grade school? Well, this is basically the machine's version of that. It goes through every single token and labels it. This one's a noun, that one's a verb. This here's an adjective. This adds some really critical grammatical context. So, if we apply this to our sentence, Sambula gets tagged as a proper noun, and sprang gets tagged as a verb. All of a sudden, the machine doesn't just see a random list of words anymore. It can actually see the sentence's grammatical backbone. Right, next up is a really cool one, named entity recognition, or NER. This is where the machine identifies real-world things, like the names of people, specific places, or companies.
By tagging Sumbala as a person, the machine now understands this isn't just any old noun, it's a specific individual.
So we followed our sentence all the way from just raw text to this enriched, tagged data. It's been chopped up, cleaned, and labeled. But what's the point of all this? Why does this whole pipeline even matter?
Well, this transformation is the entire point. We started with a messy, complicated human sentence, and through all these steps, tokenizing, cleaning, tagging, we turned it into structured data. And this final result is something a computer can finally understand, analyze, and most importantly, act on.
And this exact process is what powers so much of the technology we use every single day. Your smart assistant uses it to get what you're asking. Your email client uses it to filter out spam. Search engines use it to find exactly what you're looking for. Seriously, every time you see a machine understand language, this pipeline is humming away tirelessly in the background. It's a pretty incredible process, right? It turns the beautiful complexity of our language into the pure logic of a machine. And, it leaves us with a really fascinating question for the future. As this technology gets even better, what's going to happen when machines can understand not just the words we say, but what we truly mean?